Hey guys and gals, welcome to this edition of Sin Hardware. I had some guy on the forums ask a question about how to read voltages from a motherboard for the vcore, and someone also asked how to do it from voltage read points, like these right here. This is an active system right now running, is a G1 Sniper 3. This is one of my bench boards, meaning that it's all greased up, and I use it for benchmarking. So right here is the monitor, which is with this system. It's running at 4.4 gigahertz. Maybe we can zoom in a little bit more. Yeah, 4.4 gigahertz. I'm at 1.28 or 1.248 volts. I set 1.5 volts, but I use LLC Turbo, which is the second highest level. So there is a tiny bit of droop under load. It's only usually a couple millivolts from idle down to load. Or almost nothing at all depending on the load condition. I'm just going to use Intel burn test for my load testing. I've already run this just to make sure everything was handy dandy. And the mouse is all the way over here, so I just do an easy test just to push power and stuff like that, and we see how fast it goes. I just want to stress it out. And Intel burn test is a little weird because it does go through cycles of heavier load and then lighter load, and so I'll go over how everything's going. So I'm going to show you how this board is hooked up and everything that's going on with it. It is actually flipped upside down. Ouch. If I grab it from its heatsink, I can flip it back around. You can't do this with a discrete GPU because of the way everything is, but you can do it just like that. And that's the system. Right here we can see voltage read points. Right? Maybe I can even get a little closer. Yeah, right there. Okay. Now, so I get the camera stand. Alright, so this little voltage read point right here says vcore. The minus is all the way over here and the plus is over here. You see there's two pads. So I have this digital multimeter and I set it to volts. And then I have a positive and a minus lead. I need to zoom out for a second here so you can actually see what the DLM reads. Alright, so this is the voltmeter, right? I'm just going to put it on its side. Just balance it like that. Alright, so I have a plus and a minus, and I'm going to hook it up right here. The minus is on the outside, and this is important to remember for when we flip the board over. So I put the plus in, and then I put the minus, and you see 1.245 volts. 1.245. So 5 millivolts less than what I set at idle, because I'm not loading. Alright, now we're going to flip the board back over, and you saw that's the voltage read point. It actually says vcore. And this is meant for actual reading. Just random points along the board. I mean, you can see there's hundreds of them, thousands of them. They'll all give you different voltage readings. And they're all a product of something. Anyway, so we'll flip this around. Alright, good. Everything worked well. Good, good, good. Sorry. This camera stand. Anyway, so now we're on the back. Now here's the other point that I'm going to read voltage off of. Let me see if I can sharpen that up. Alright, these are the bottom of capacitors. You see there's 4 of them right here. These are the pins that come up, and you can see the mounting bracket is barely over it. These are the legs of the chokes. You want to see something cool? You guys want to see the switching frequency? That's something you can do in this condition. Alright, so we have the DM right here. And this digital multimeter also has hertz right here. So I can switch over to hertz. And it's not reading anything. And you only need the positive or negative leg for this because it just reads a frequency. So you're reading like 60 hertz right now, fundamental frequency. Now, what happens if I stick it to the leg of the inductor not facing the CPU? So I'm doing that right now. And you see that? 258.8 kilohertz. that's the switching frequency is running at right now on auto. And that sounds about right, right? But if you go on the other leg of the inductors, the one closer to the CPU, they'll either read 0 or 60 hertz or 50 hertz. This is reading 10. Oh, I shouldn't read that. So now this needs to be calibrated. See, this is now 3 hertz. So if it doesn't get a very high frequency, it's not going to pick up on it. But if it hits 258.8, it'll pick up on it because that's high enough. So I can go to this other one, that'll also read the same thing. And this other one, and that'll read the same thing. But if I go on these here, it's like 44 kilohertz, then go to the next one, or touch it with my finger, it goes to 60 hertz. So it's basically nothing reading at these little points. If I keep it there long enough, it should go to 0. Right? So that's just the switching frequency. Anyways, let's focus on the voltage, sorry. So, I put my volts on. I need both positive and minus because I measure at the leg of the capacitor. One is positive, one is negative at the leg. I believe the negative is the same side that the thing was on there. So negative leg touched, positive leg touched. 1.246. So 1 millivolt difference. I think it's reading from the same thing. Oh wait, 2.45 now. So it's exactly the same. Anyways, now I gotta go turn on the load. Alright, ready, set, start. Alright, I have started the load. You can hear the fan. Watch the voltage reading because I'm gonna hold it here for a little while, alright? And this is on purpose because I want to show you guys how Intel burn test loads. Alright, so you can see that perfectly. 1.249248, and it's going to drop back down after this. There you go, 1.241. That's right before it spits out a reading. Now to go back up. There we go, 248, 247. So to go up, whoa, my finger got loose there, but it's 1.248, and then it'll go back to 1.241 or a little lower after that. Not yet, but real soon. So I'm going to wait for it to happen again so you see it's a cycle that Intel burn test goes through. There you go. Back down to 242, and then it'll go back to 241. There you go. Alright, now let's move voltage read point. It's the same Intel burn test, right? It's running. But now voltage read point time. Alright? Now, these voltage read points, they come through exactly where they are. So the furthest one over here is going to be the negative, and the next will be positive. I can do it like this if you want to make sure I'm reading from the point. Just make sure you can get that point. Alright, 242, and now to go back up, 1.248, right? That's the same voltage, right? And now we'll wait for it to go back down just to make sure. Don't do this if you're not me, because I have specialized tips for this, the leads from this voltmeter, so they're like needles. I'll zoom into it real close if you want to see. Now it's going back down to 1.242, right? Just like the other one did, didn't it? And it'll go back up soon. There you go, back up soon. And it went up a little bit. So they're basically 1 millivolt apart, and the thing fluctuates by 1 millivolt, and that's on the second strongest level of LLC. And the strongest level actually increases everything per load. So same frequency, same voltage, and you see it's currently burning. So, ladies and gentlemen, I just wanted to show you how actual voltage read points is. The capacitor, the ones that are can typed and sitting there, their legs are optimum. These 4, actually this one on the edge will show me VTT, but these 3, if you find a group of them and they're bunched together, these ones are going to be CPU vcore. Ah, PCB's a little hot. Nice. Anyways, you guys want to see how cool these little tips are? Alright, let me see if I can focus into this. Yeah, just like that. They're like needles. They're really, really fine. So you can get both plus and minus, and they just attach like this. So it comes in a pack. You can buy it. Anyways, I'll talk to you guys later. Thanks for watching.